Hello to you once again. In today's lesson, we are going to look at the forms of a first order differential equation. So the first form we are going to look at is what we call the general form. The general form. And I'm just going to write the notation for it. So the general form is of this form: f of x being an independent variable, y being a dependent variable, and dy dx being our first derivative. So this any equation you see of this form where our variables and derivatives in on the left side and they are all equal to 0, we call that the general form. Okay, and let me write an example here. An example is 2xy plus x squared plus y squared dy dx being equal to 0. So this right here is in the general form. We can see our dy dx here. We can see our x variables and we can see our y variables as well. So that's how we are able to identify a general form. The next one is what we call the standard form. Standard form. And that one also is written as dy dx is equal to f of x, y. So in the standard form, we have dy dx. Remember, we are talking about the forms of our first order. So it will only contain dy dx. Okay. And the dy dx will be on one side of the equal to sign. And our variables or our function of the variables will be on another side of the equal to sign. So with the standard form, with respect to our previous example, if we are to write it in the standard form, it will be like this. Oh, sorry. It will be like this. Dy dx equal to negative 2xy over x squared plus y squared. So you can see I have this on one side and I have this on one side. That's what we call the standard form. And the last one I'm going to talk about is what we call the differential form. The differential form. And what is this about? This is how it is written: m of sy dx plus n xy dy being equal to 0. So this is how it is written as. Okay, so we can see here that we have some variables being allocated to our dx. So we have a term of dx and we have a term of dy, and they are all on one side and equal to 0. If you see anything like this, then it is what in the differential form. So with our previous example, writing it in the differential form will be 2xy dx plus x squared plus y squared dy being equal to 0. If you want to be sure of that, you can see in our general form, we just had this and we had this here. So we could have just picked this dx and multiplied through by dx. eh, yeah, multiply through by dx. You see, we'll have dx multiplying this, and this will cancel out. Okay, so that's how we form a differential form. So in the next page, I'm going to, in our next page, I'm going to try to convert this first order differential equation into our differential form. So the first thing we are going to do is to expand the bracket. So we are going to end up with y square y prime minus y being equal to x. And remember, in our differential form, they are all on the left side and they are equal to 0. So let me bring my x inside. So we have y square y prime. Uh, we have y square y prime minus y minus x being equal to 0. And the next thing we are going to do is this. So we can write y square y prime. We can write these two variables as one term. So it becomes minus y plus x. Okay. And we all know that y prime stands for what? Dy dx. So I'm going to write y square dy dx minus y plus x being equal to 0. Okay. And this is just change of subject. So we are going to multiply through by dx. And in so doing, we have y square dy minus y plus x dx being equal to 0. Are we there? So comparing it with our differential form, we can see that we have m, because this term contains only y, we have m of y dy, and it is minus n of xy dx equals to 0, because this term contains both x and y. So this is how we converted our differential equation into a differential form. So that'll be all for this lesson. If you have any comments, you can comment below, and remember to subscribe to the channel. I'll see you next time. Bye bye.